All right, so this structural analysis course is all about indeterminate structural analysis. Okay, so we're going to learn how to analyze indeterminate beams, frames, trusses, even arches. Uh, everything in this course, every example, every problem in this course is an indeterminate problem. But just to start, we give you an idea of what's the difference between this analysis and what you have learned so far. Let me give you an example. If I have a beam like this, and let's say it is subjected to a uniformly distributed load W, then and let's say its span is L, and let's say this is A and this is B. Can you find out the directions on this beam? Can you give it a try? Do you think there will be any problem? Okay, please go ahead, find out these directions. How do you get to know it is indeterminate? Sorry? How many unknown direction forces do you see in this beam? 4. In total, there are 4. So 3 over here and 1 over here. Okay. So how many equilibrium equations do you have for this 2D beam? 3. Summation fx, summation fy, and summation m. So it means we have 3 equilibrium equations and total 4 unknown directions to solve for. So if I could just list them down, the unknowns are, you know, I could say, maybe if I could give them a few names. At A, I have, you know, fx at A, fy at A, maybe just a few names, ma, and maybe I could say, maybe a better representation would be like something that appeals more to you, sorry for that, RA X, RA Y, and then we could say RB Y. So these are the 4 unknowns we need to find. And how many equilibrium equations do we have? Summation fx equal to 0, summation fy equal to 0, and summation m equal to 0 at certain point, whichever you like. Now, so you can figure out that it's 1 degree indeterminate. There is one additional unknown beyond the number of equilibrium equations available. So you may say there are 4 unknowns and 3 equilibrium equations are. Somebody may say that as there is no horizontal loading on this beam, so when there is no horizontal loading on the beam, this horizontal reaction at A is going to be 0. So you may say that, yeah, I can find this equation, but I can find this out, but if you try to find this out, you are basically consuming 1 equilibrium equation. So the situation would be like you have 3 unknowns left and 3 equilibrium equations in your account. Okay. So at the end of the day, you still have 1 unknown reaction beyond the number of available equilibrium equations. Okay. So what's the way to solve this? One of the ways which we are going to start today is if somehow we are able to determine one of these 3 unknowns without using our equilibrium equations. So we have the 2 equilibrium equations still in our account, and somehow we find one of these 3 unknowns, we will be left with 2 equations and 2 unknowns. 2 equilibrium equations and 2 unknowns. So then we can easily solve. For example, if I get to know this maybe this RBY somehow without using equilibrium equations, I'll have 2 unknown reactions and 2 equilibrium equations in the account, and I'll be able to solve for the 2 unknowns using 2 equilibrium equations. It becomes a simple problem in that case. So the whole so this method starts with identifying the unknowns and kind of picking or selecting one of the unknowns as the primary unknown. We would call this for example, if I say that I will find this one out first without using equilibrium equations, and then I'll come back and solve the rest of the system, then this one is called the primary unknown, and we call it redundant. You better write down redundant for this. Redundant. So redundant is that unknown which you treat as the primary unknown in your problem, primary unknown reaction force in your problem, and then once you get to determine this redundant without using your equilibrium equations, then you can solve the rest of the system. So it is the one that you find first, and then you say, okay, I'll find the rest by using the equilibrium equations. Okay. So you're clear about redundant? Now it's so if you say that this is my redundant, and you need to find this out somehow without using equilibrium equation, I'm going to discuss how that somehow looks like. But at least you know that if this redundant is found without using equilibrium equations, we are going to be able to solve it. Now, before getting into that procedure, I want you to know one thing which you might have studied before. If this is a